Number 1, find the number of possible outcomes. Kevon, part A.
I did NCR and calculate 16 and 4, 1820. Hold on. Right, I said it right. I said it right.
Yeah, 1820 or 1820, either way is fine. Questions on that? It doesn't say which one will be first, second, third, fourth. It just says a group of 4. Okay. Part B, Jarmis. No.
4 and 2.
2. It only says national champion and runner-up.
12.
Questions? No questions, Terrence? So why is this one a permutation? Because position matters. It's it gives you positions that they're going to finish in. They're going to finish in national champion and runner-up. If it says first, second place, if it's a password, if it's a group of people lined up for a photo, if it's books arranged on a shelf, order matters. Position matters. Number 2 talks about rate of change, which is another word for if I say y equals mx plus b, what does the m stand for? Slope. So what I'm looking at here is x equals 0 and x equals 4. So right there, and 1, 2, 3, 4, right there. So what's the rate of change? The average rate of change as it goes from 0 to 4. Well, the run is 4. What's the rise? Yeah, it goes up 8. 1, 2, 3. Yep. It goes up 8. And so the rate of change is positive 2. Okay. That's not something that we explicitly do. That's kind of like a figure it out, use your Algebra 1 knowledge, kind of not common sense, but figure it out. Okay. Questions on either part of the warm-up? Yes?
So, rate of change can be rise over run?
Yeah, rate of change is the same thing as slope. Yep, rise over run. When you get into calculus, you'll do something called derivatives to find the slope of a line that would be tangent to that curve. That's it's pretty fun stuff. It's pretty easy actually, not too hard. People want to make it sound hard, but it's not that hard. Okay, take your warm-up side to side and look at today's notes, and yesterday's notes, I guess, actually, in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Really basic probability review. All stuff that you already know how to do. Okay, and I'm going to speed through this pretty quickly. Here's my situation right now. I'm rolling 2 dice. Each one has the numbers between 1 and 6 on it. And I'm just going to make a chart that shows every possible outcome. Okay? So if I roll a 1 and a 1, that gives me 2. If I roll a 1 and a 2, 3, 4, 5, 6. 6 and 1 gives me 7. Yeah, it does look, it's not the best print job. Sorry about that. 1 and 2 gives me 3. 1 and 3, 4, 5, 6, 7. 2 and 2 is 4. Just fill this out along with me on your chart. 5 and 4 gives me 9. This is a chart of the sum of every possible combination when you roll 2 dice. So this is kind of helpful. You can just look at it and tell which one of these occurs the most. You can see that the most frequent is 7. There are also a lot of 8s and 6s. Okay. So to find probability, all we do is the number of favorable, or the number of the event, divided by the number of total possible. Okay, so let's look at some examples. Well, a quick review here. probability can range from 0 to 1. So 0 to 1 or 0% to 100%. We'll write every answer as either a fraction or a percent. If the probability is 0, that means it's impossible. If the probability is 1, it is definitely going to happen. So here's some examples. What is the probability of rolling a 5 with 2 dice? So all you want to know is how many 5s are there and how many total possible events are there. So how many 5s are there? There are 1, 2, 3, 4 5s. 1, 2, 3, 4 5s. There's 4 ways you can roll a 5. Looking right here. 1, 2, 3, 4. And how many total rolls are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 33, 34, 35, 36. So 36 total possible combinations. Use your calculator to reduce the fraction if you need to. And then convert it to a decimal and move the decimal 2 places. So this would be 17%. This would be 1.8%. Just move it to the right 2 places. In this case, I think you get that, right? Round your percent to the nearest ones column, the ones column. I don't care about, 11.387. I don't really even care about 11.4, just 11%. Example 2, what's the probability of rolling an even number? So how many of these are even? 1, 2, 3, 4, 5, 6, 7, 8. I agree with you, Cortavius. If you count all of these up, you would get 18. So 18, this time 18 over out of 36. 18 favorable, 36 possible. And I think you can convert 1 over 2 in your head. That's 50%. Am I moving too fast? All review. Okay, let me skip this for now because this is just meant to make you feel the importance of what we're going to do next. So just know that the next thing is important. So take your paper and flip it over. Hard work. Mutually exclusive events, okay? Mutually exclusive. Anyone have a coin on them? A coin? A quarter? A nickel? I have them in my pockets. Okay. Mutually exclusive. Another word for mutually exclusive. Another word for mutually exclusive is independent. Mutually exclusive or independent. So here's what I mean when I say independent and probability. I'm going to flip the coin, okay? What do you think it's going to be?
Tails.
So you don't really know. Tails. So I just flipped it once. If I flip it again, does that mean it's going to be tails again? Well, it just made it tails. It's going to be tails again. For sure.
No.
So wait. So the flip I just did isn't going to change my next flip? Are you sure? Okay, wait. It is going to change?
I don't know.
So wait, if I flip 50 tails in a row, does that mean that my next one's going to be tails?
No.
It doesn't?
No.
Oh, each flip is different?
Yes.
Each flip is independent. Okay. One flip of the coin does not affect another one. Man, I had 130 tails in a row. The next one's going to... No, it's still going to be one half. Might be heads, might be tails. Got any more? He said, yeah. Now let me contrast that. That is independent because every time you calculate the probability stays the same. Let me contrast that now. How many pencils do I have here? 4. Okay, and how many pens? 3. So altogether,
7.
7. Okay. What's the probability of me pulling out a pencil right now? 4 pencils, right? 7 total. So 4 out of 7. So I'm going to go and I pulled out a pencil. Okay. I'm not going to replace it. I'm going to leave it out. Now, things change, right?
50%.
Okay. So now not 4 out of 7. Now 50% or 3 out of 6. Okay. I'm going to close my eyes. I'm going to pick one. Of course, I took a pencil. And now I'm going to say, what is the probability of getting a pencil again? 2 out of 5. Okay. To calculate the probability of getting 3 pencils in a row, you would multiply those fractions together. So let me show you some examples here. The coin is independent because it doesn't matter how many times you flip tails, it's still going to be 1/2 probability. Okay. The previous flip doesn't affect the next one, but with the pens and pencils, it does. Because some's getting taken out, exactly. Because it's not getting replaced, not getting put back in. So here's an example. What's the probability of tossing a heads? What is it? Tossing it 3 times in a row. Heads 3 times in a row. Okay, so the first time you flip it, what's the chances of getting heads? 1 out of 2. The next time you flip it, does it change? It's still 1 out of 2. It's independent probability. Like the third time. Okay, we all know how to multiply fractions. Listen, don't waste time in your calculator right now. Look, multiply the numerators, multiply the denominators. Now you might need to use your calculator to convert to a percent, but 1/4 is 25%, so what's half of 25? 12.5%. Does it matter to me if you use your calculator to do it in your head? Nope. As long as you get it right, you're smart to me. Speed is an illusion. Except for when you're taking ACT. All right, let's do one of these that are dependent now. That was independent. Let's do a dependent. Look at example 5. It says a bag contains 6 red and 11 blue marbles. So this is like my pen and pencil example. What's the probability of successively drawing without replacement 2 red marbles? So first I want to get a red marble, then I want to get another red marble. The first time I go to pull it out, what's the chances of getting a red marble? 17, good. So you need to calculate the total number of marbles. So 6 out of 17. Now it says, do I put the marble back in the bag?
No.
No, it says without replacing it. So now things change. How many marbles are left?
4 out of 6.
No? 5 out of 16. Yeah, I took 1 red out, and that also means I have 1 less total.
Okay.
I took 1 red out, I have 1 less total. And that's it. It only wanted 2 red marbles, so multiply these together, 30 over something, which is equal to something. 17 times 16 in my head? I got other things to store up there.
272.
11%? I'll do that in my head, sorry. Sorry I couldn't do the other one in my head. My apologies. My apologies. I calculated there were about 9 15s and 136. If there are 9 of them, it's 11%. Okay, this is the exact same thing, so don't worry about it. Your homework on this is these. I'm going to do 2 of these with you, and then I'm going to look at the other worksheet that you picked up as you walked in today. Practice. A die is rolled twice. Find the probability. Probability of the event signifies probability of the event happening. Look at number 5. It says, what's the probability of rolling a 4 and then not a 6? So let's find out these 2 fractions. What's the chances of getting a 4? How many sides are on the dice? 6. Okay. So that was my first roll was what's the chance of getting a 4? 1 out of 6. Now, we good on that? 1 dice, yeah, 2 times. I'm going to roll it once, and then I'm going to roll it again.
5 out of 6.
Why 5 out of 6?
Because it's 5 other numbers than 6.
There's 5 other numbers. It says not 6. So how many will satisfy that? 5 of them. What will work? 1 would work. 2 would work. 3 would work. 4 would work. 5 would work. 6 wouldn't work. So 5. Still thinking of the 2 dice. 5 over 36 as a percent. 14%? 16%. That's my guess.
Okay.
Yeah. On what? Oh, so what is it?
Do you want to round it?
14%. 13.8. I mean 0.
Yeah, 13.8 or 14. Questions on that one? Oh, you're right. We should have. Thank you. We should have.
Hey.
Thank you. My apologies. We should have. One more. Ready? This one's going to throw you a little bit. So prepare yourself. Which one did I like to do? We'll do number 12. Okay, here's the situation. You got 6 cards in front of you. Underneath each card is a certain shape. So what are the shapes? Star. Does it repeat any? Star, square, circle, diamond. Okay, so it didn't repeat any, right? They're all different. The cards are placed face down, and what you're going to do is you're going to pick 2 cards. You're going to take one. You might keep it, or you might put it back, and then you're going to take another one. Okay, so let's take a look. Number 12. A polygon, and then a hexagon, and it says no replacement. So when you take the first card out, you keep it. So
1 out of 6 means
something out of 6, and then something out of
1 out of 5.
5. So let's figure out what they are. First of all, what's the chances of getting a polygon?
1 out of 6.
Well, how many of these are polygons? Is a star a polygon?
Yeah.
Hold on.
A star is a polygon.
Let's go. Let's do both sides.
A square is.
Square.
Diamond, a rectangle, and
A rectangle.
a circle isn't because it doesn't have any sides.
Right. Polygon means many sides. Yep.
It's 2.
So everything but the circle. 5 out of 6. Let's take a look.
Hexagon 6 out. 5.
So that's
6
6
out.
Six out.
That's a pentagon. So a hexagon 6.
Still waiting for somebody.
It ain't none of them. I don't know.
Is a hexagon 6 out? That a run thing?
Yeah, no,
What's a hexagon?
If it's 1 out of 6,
it's not. It's not one of them. What is the hexagon?
You trying to figure out what it is?
I know what's going up there.
That's how I feel.
Said
They
8.
didn't give us a choice to choose the hexagon.
0 out of 30. 0%. Why you do that when it comes to pop?
So they have been saying that.
Hexagon does have 6 sides to settle that debate.
Thank you.
What's up? What? It is. Nope. Rest for you for homework. One more thing. Yep. Yep. Now look at your second sheet. Your second sheet takes everything we've done over the past 2 weeks. Standard deviation, mean, median, mode, range. Bless thee. Probability, everything that we've done. Jumbles them all up, gives you a chance to prepare yourself for whatever may come. For whatever may come. Yep. You have about 20 minutes left to work. I want you to work on your own silently for the first 10. After that, I'll take questions.